Hi there friends, welcome to another demo on Tableau. I'm going to show you how you can create a text table or worksheet in Tableau. To start, allow me to create a text table very quickly here before I dive into the details of what the building blocks are. This is called a text table or a worksheet or a table or even a crosstab. It depends on the naming. The naming convention depends on the type of environment where you come from. In Excel, this would be called a table or a worksheet. In Microsoft Word, this would be called a table. In Tableau, you could call this a dimension-based text table or simply a table. If it involves cross fields or cross columns, then you can call it a cross tab. It all depends on the actual visualization that you're creating. But in this table, as you can see, we don't have any involvement of any chart or any specific visualization here. We simply have categories of subcategories of items and their total sales aggregated next to them. So how do we do this? Let me start from the beginning. When you bring a dimension variable onto one of your row column shelf, you're automatically, if it's a dimension being a categorical variable, you're automatically creating a field, a column of that categorical information, which you have it here. And then it also gives you a placeholder for your aggregation, for your measure values, because you brought the categories, but how are you going to measure it? What would you like to measure them on? Are you going to only keep the categories, or are you going to also apply measurement to them? Because a category without measurements, without any type of numerical indication, does not really convey a lot of information. So in which case you can drag one of these measure variables here onto the space holders. For instance, profit could be brought onto the text. As you can see, automatically we have aggregated sum. And remember, it's when we double click on your text on the variable that's brought onto the text label, you can see that it's the profit, but aggregated for to bring in the sum, the total of the profit, because each of these categories actually have a bunch of a bunch of distinct values. Each of these, like for each of these categories. So, for example, accessories, maybe there are thousands of sales. You don't want to bring all these sales and their distinct values here, like $2, $3, $4, all the way down the row. Instead, you would like to bring an aggregated value of that particular subgroup, in which case, which we just did. We now have a table here, a text-based, although it's called a text-based table or categorical table, but we would always have some sort of measurements applied to the table in order to be able to explain, convey meaning from that table. So that's one of the ways that you can create such tables. Another way is and this is just to make sure you understand, and there's not a single way to do something in any programming language or software, and Tableau is one of them. It's very artistic, so you take the liberty of doing things the way that you want, and to be able to create this artistic way of doing things. So another way would be to, let's say, you bring again the dimension variable onto your row. Again, you create a table here, and then you can bring the measure variable actually next to the dimension variable onto the row. And let's see what will happen. As soon as you drag and drop it here, bingo, you would still keep the table format, but you're going to get charts. You're going to get graphs associated with each of these subcategory blocks. And why? Because we have a dimension and measure. As soon as you introduce a dimension and measure, as soon as you introduce a bar and a value, you're automatically creating some sort of visualization. Now, to bring the profit value as a numerical value and in the form of a table, you will need to change this from continuous form to discrete form. And you simply do that by clicking on the actual variable on while it's on the row shelf, and click on the space, and bingo, and we now have the profit listed here for each of these subcategories, just like the way we did it with the text placeholder. So that's one of the ways, and let's look at how you can create crosstabs. And crosstabs are very important, especially when you're looking at multi-dimensional analysis of your field. So for in crosstab, it's a little bit different because you're looking at two categories of variables, but then you're also looking at a measurement that's shared between those two variables. I'm going to explain what I mean by that. First, let's bring a segment onto our column. Right, there you go. And as soon as I brought the dimension variable onto the column, I only get a table. Now the second thing I want to bring is the second variable will be another dimension. I would like to select something that's short, maybe region here, and put it on the row. And as soon as you do, you have a crosstab. You have a cross tabulation. You have a table that's crossing each other by columns and rows. So we have a crosstab. Now the only thing missing is the ABCs. These are the placeholder for your values. Otherwise, you don't have nothing to project here in terms of a numerical value. So let's say we were going to now introduce a measure a variable onto the crosstab, and we do that by simply dragging the measure, in which gets the profit, and dropping it onto the text placeholder. And there you go, placeholder. And there you go. Now we have the sum of profits for each of these categories, where they interact. So, for example, the consumer segment in the South actually had a profit of 26,914. The consumer segment in East had 41,000, or the home office segment in West had 16,530. So this is a very good way to be able to project two categorical dimensions of our data using a particular measurement. And I don't know if you have used contingency tables in the past, where you apply statistical analysis such as chi-square, where you look at two specific dimensions of two categories. You can also do that by simply putting on your filter both segment and region, and then filtering them out by two variables each. And there you go. You now have a 2 by 2 or two-way cross tabulation for two categories between region and segment. There's a lot you can do with the tabulation. Although again, it's text based, but you can also do a lot of calculations within these tables. And lastly, I just want to make sure that I mention this, that uh, while you're bringing your measures as aggregates onto your placeholders, remember that you are given an option of selecting a variety of measurements or calculation types here that would allow you to be able to look at different mathematical and statistical dimension of your variables. Like for instance, we have the sum of profits here. Actually, we can look at the average of profits for those given variables. And there you go, we're now looking at the average. I'm going to have a separate video where I'll explain what each of these statistical indicators mean, and in the context of Tableau, meaning how you use them in Tableau. But each of these statistical tests and descriptive statistics actually need more explanation for you to understand. Right? Please look for my video where I'll be describing basic descriptive statistics using measures in a table on Tableau. But just really quickly, median sum is the total aggregated total of the ordinary values. Average is of course the average number. While we have what we do is you get the summation um, of all your data points, and then divide them by their total distinct total counts. Median is the midpoint of your distribution. Count is pretty much count of all of your data points, all of your records. Distinct count is any record that's distinct, that is not duplicate. So minimum is the least value in your distribution. Maximum is the highest value in distribution. Percentile is the position, is a percentile position of your data point in the distribution. Standard deviation is the distance of your data points from the average that's standardized in terms of standard deviation. And there are two types: standard deviation for the samples, which is in a statistical law, it's n minus one, so it will be the population data minus one, and then the standard deviation for the population, that will be the n. There won't be a subtraction of one from the total population, but remember that you will be looking at standard deviation for the sample and standard deviation for the population. In our case, would be the sample, because a lot of times we get sample data rather than the population data. Same thing with the variance. Variance is a statistical indicator of how much your distribution vary, and there are a variety of variance tests and descriptions that I will cover in future videos. And again, same thing applies to variance, where you have variance for samples and variance for the population. Thank you so much for your time. Until next time.